Talking about friction as being any force that is going to oppose the forward motion of an object. So in this case, if I've got my horizontal surface here and I've got my object or my body, if I want the object to move in this direction, which direction is force going to go in? Force is going to go in the opposite direction. Now notice how I made the forward motion a larger arrow than, the force opposing it. Because if the object actually is moving in this direction, then it's moving at a greater force, okay, than the force that's opposing it. If friction becomes greater than, or equal to, I should say, than the drive force, then that's when it won't actually move. It'll be stationary. So if I'm on my inclined plane here, okay, and I've got my box, and I state that, okay, this is actually, positive x, and this is positive y. If I want the object to be sliding down in this direction, what direction is friction going to go? Friction will go in the positive direction here, right? So friction is just a force that opposes forward motion. That's all it is. Whether your forward motion is to the left or to the right. I could have easily changed this axis to have positive x going down. And you're going to see that when you actually manipulate that later on, you're going to do that. Because if you want your positive or your forward motion to be positive, then you can manipulate your axis to say, okay, well, in this case, in this situation, forward is going down the hill. Because that's where the object's going to want to go. Okay? So when we talk about friction, all right, we know that friction opposes forward motion, but here's the interesting thing. The friction that an object is going to experience is going to be dependent on something. It's not going to be the same everywhere. What does the friction depend on? The surface, the type of surfaces that are in contact with one another. This morning I wiped out. I fell on my dog. My dog broke my fall. And it's a big dog, so it's okay. Poor thing. But it was icy. All that rain that we got last night, towards the end of the night, landed on the snow, and it was warm and it melted, and there was a sheet of ice outside my house. So my rubber boot on that actual ice had a different coefficient of friction. There were two different surfaces at play there, and friction was different when those two surfaces came into contact than, let's say, when my rubber boot was walking on the wet asphalt. Okay, the pavement. Which one do you think had, more friction? The asphalt or the ice? The asphalt. So I didn't fall. I didn't fall on the asphalt, I fell on the ice. Now when we talk about the force of friction, friction takes into account the surface or the surfaces that are at play here. And because we're actually numerically calculating friction as an amount of force that's hindering or stopping forward motion, well, we need to be able to associate a number with the interactions of different surfaces. And those different numerical values are known as something called the coefficient of friction. Okay? The coefficient of friction is very important in a friction formula. Because just like the force of gravity is equal to the mass times gravitational acceleration, well, the force of friction here is going to be equal to the coefficient of friction, and this is the Greek letter mu, okay, times the normal force. But in reality, we could also say that the force of friction here is going to be equal to the coefficient of friction times negative force of gravity, right? Because we know that Fn is going to be equal to negative Fg. On a horizontal surface, these have the exact same magnitude but the opposite direction, right? Does that make sense? So when we talk about friction itself, we've got to know a few things. We've got to know, first of all, whether the object is stationary or static, or whether it's moving, it's kinetic. Okay? And we also have to know what two surfaces are coming into contact with one another to determine which coefficient, which numerical value we're going to use. Because if we look in our notes, on page 11 of your notes, you have a table there with a variety of substances that come into contact with one another. So you have things like rubber on dry concrete versus rubber on wet concrete. Okay, you've got steel on lubricated steel. And that comes into play in something like an engine, when two parts of an engine are actually rubbing together. Okay, when you go get your oil changed in your engine, or you go get your car lubed, that actually means they go and they pour grease inside your car and they coat a variety of different metal parts so that when they actually rub into one another, okay, there's a little coating there of a lubricant so that you don't actually wear down your engine that much longer. It lasts that much longer. Because if an engine, the more that you have steel rubbing on steel, the more heat you're going to get. That's going to melt and warp your engine, and your engine's just going to seize. It's going to stop working. Okay, you often hear of people going in to get an oil change in their cars, and the mechanics they get busy and they forget to put more oil in the car. Or they don't realize that they haven't refilled the oil once they emptied it. And then they put the cap back on the actual car, the area where you pour the oil, and then the car drives away, and then, not even 5 kilometers from the actual garage, the engine breaks. The engine seizes. And when you have an engine that's seized, your car's done. Okay, that's happened before. Okay, and then the garage is on the hook for not having replaced the actual oil. So this stuff is actually really important. Okay? So when we talk about the actual force of friction, there's a few things we've got to know. Got to know the mass of the object. Why is the mass of the object important? It's going to help us calculate what? It's going to help us calculate Fg, and by knowing Fg, what does that let us know? It lets us know our normal force for that object. And so if we've got our normal force, then what else do we need to know? We need to know whether the object is stationary or moving. Okay, and if it's not stationary, what coefficient are we using? We're using static or kinetic? Kinetic. Okay, what else do we need to know to determine which coefficient we're going to use? We need to know the surfaces in contact with one another. Okay, so it's really not a complicated formula, but there are a few things that you've got to know and understand. Okay, you got to know what mass you're dealing with for your object. You've got to know what surface you're on, and you've got to know whether you're moving or standing still. Because all of those are going to play a part in determining what coefficient of friction you choose and what your normal force is going to be.